I studied AI in my undergrad and in my master's program, and I really enjoyed it academically, but I also realized that I spent a lot of my time actually at the product realization lab at my university, which is essentially the machine shop where you can learn things like laser cutting and 3D printing, and I realized that I actually am very interested in the hardware space as well. And I found that Normal was in this really unique intersection between AI and hardware, and I just wanted to learn a ton more about it.
In this era where the traditional paths to scaling, Moore's law and Dennard scaling are breaking down, and we're getting a lot of wins out of kind of specialization in chips that are kind of unconventional, different, and narrowly tailored to different tasks. And so this is where I think that there's innovation in EDA that's required, not just to speed up what we're already doing, but to make it possible to actually design these new chips.
I think that it's important to really remember that the end user is just that design verification engineer who day to day is writing tons of stimulus and tons of test cases and just thinking what really is the thing that makes their life easier. Like I'll, in one day, be doing a sales demo, and then I'll be writing a spec for a new feature, and then I'll be working with the engineer on the evaluation of a certain feature, and then I'll be working with other PMs building out design mocks, and then I'll be working with some people on writing a blog post.
That's one of the things I really like about the discipline of AI is just how ruthlessly empirical it is. There's every week there's a bunch of beautiful and interesting ideas that are posted on Twitter, but at the end of the day, people say, well, show me the benchmark and we can test how well it works. And I think we have a kind of a core belief that every idea can be tested, it can be simulated, it can be benchmarked.
What really convinced me was the tape-out. I think that is a very tangible accomplishment. I don't really know of peers who have accomplished something similar in scope. It takes a level of complexity that you don't get at any kind of run-of-the-mill tech startup. And it felt obvious to me that this was the best time to join the company.
So you have the reviewability part where you see that they're able to actually understand how the collateral that's generated is tracking towards 100% functional coverage. But then you also have the fact that these tools themselves are very powerful standalone tools that do help them generate very interesting things that would have otherwise taken them on the order of months. And we can speed that up to on the order of minutes. And I think that when we go to these customers and show the product, that is a pretty jarring and exciting thing to watch, because it's in the same way as the software field where now we have these multi-purpose coding agents that generate thousands and thousands of lines of code in a matter of seconds. It's almost the same reaction that people are having here, where they're seeing a process that would have normally taken them months be done in front of them in a matter of minutes.
And another question I had is, where is there room for branches of physics like thermodynamics to make big contributions in the 21st century? Historically, the development of things like the steam engine and all kinds of engines, and then different branches of physics created a wealth of new technologies in the 19th and 20th century, and I think that we're also getting closer to getting an answer to that, which is that by bringing in thermodynamics and some of these theoretical ideas into the semiconductor industry, there seems to be some potential for a large impact there.
I feel like also one of these original questions that made me think of is, how can I surround myself with the people that would be excited to teach me about every part of the stack? And I think that as someone who maybe just started at the highest level of the stack working and studying AI, I think it was most important that people around me, when I get into the office, are telling me about how the intricacies of a memory chip work. And that was something I've never even thought to study or even was exposed to at anyway, or how these exact linear algebra paradigms allow for more energy efficiency gains. And that was something I've also never conceptualized. And I think just having people here who are invested in your intellectual growth and personal growth, and asking myself, how can I constantly surround myself with those people, has led me basically to Normal.
Before Normal, I was working at Graphcore on a large-scale AI accelerator. Big companies mean more meetings, more layers of management to get your ideas pushed through, more discussing things that aren't really to do with the engineering. So that was the push. And then the pull with Normal was having seen the technical challenges we were struggling with, power consumption. the sheer scale of things, where this stuff goes 5, 10, 15 years from now, and how we're reaching the plateaus of what you can do with what we've been doing for the last 30 years to address those problems. And Normal was suggesting a way of thinking about it completely differently, a novel way that, to be honest, I didn't fully understand, which was part of the excitement.
So what's different about verification? The fundamentals are the same, but what we are changing and innovating is our application of AI to that space in all facets of that space in terms of comprehension of architectures, feature understanding, stimulus generation, test bench creation. And then what makes Normal truly unique, because we are also working on silicon, we are able to test our own verification EDA tools against the designs as we build them. And so we have this very nice closed loop where we can take feedback from the design work we're doing and feed that right into our tools and improve them for our own use and then for our customers.
For me, autonomy is, if I'm responsible for the outcome, then I'm 100% responsible for deciding how I achieve that outcome. If I get an intercept in between those two things, if I don't have total control, but it's my fault if it goes wrong, I can't cope with that.
All of AI is built on GPUs. The diffusion models are inspired by a physical process, and we think there's a different way to accelerate these versus blind map models. It's hard, no one's done it before. This is stuff you can't read from a textbook, this is stuff you won't read papers about, but we're trying. We've got some unconventional ideas, and we've got a sort of goal that we're going towards, which is diffusion, and we're trying to marry those in the middle. You're going bottom up, so you get all the crazy advanced research from unconventional stuff, and we're also going top down, from the application down. So you're very grounded to what the goal is, alongside having this sort of research flexibility. So I think that's quite different, and you don't really see this anywhere else. Yeah, I think you have to be unafraid to do something wildly different.
Yeah. The EDA side of thing is exposing me far more than I would have been if I was just a customer of EDA to all of the possibilities that I can go through. I'm already rethinking how we can structure the teams, how we can restructure the process we use to build chips. Working with the EDA side has just opened my eyes to how this stuff is already changing, how it's going to change, and how you need to be part of that change, otherwise you're going to be left behind.
I think I'm just attracted to the hard problems. I like doing new stuff. I like doing things that nobody else is doing. I like doing hard things.
We've picked up two very difficult problems we're trying to solve, so it doesn't get a lot harder than this in some ways, and that's just exciting to be a part of, especially with the team that has the breadth of experience that this team does.
The great thing about the problem we're trying to solve is that you don't really compartmentalize it into that 9 to 5 thing. It just becomes what you do. And we think we're going to the pub to relax, but we end up talking for an hour about some algorithmic problem that
there's a whiteboard there. The whiteboard would be...
Right before Normal, I was actually at Meta, and I was there for 6 years. Before that, my life has been mostly co-founding startups. So I've co-founded 6 so far.
Most recently, I was at Google X. We were working on a moonshot focused on ocean health. And that was incredibly exciting because it meant that we got to play with AI technology in an applied sense.
Most companies or most startups, I think, take an existing technology and they apply it to an underserved market, which is a very sensible approach for a startup to take. We're actually pushing the boundaries of AI and silicon, and that makes it such an interesting place to be.
The one aspect of the culture that I particularly like and is very attractive is respecting the opportunity. We're a unique group of people with a unique talent set, working on a unique piece of technology at this particular moment in time.
I really value transparency and kindness. And one of the things I noticed at Normal was that that was part of the culture here. I think we have to be ruthlessly transparent and ruthlessly honest with ourselves, with our colleagues, with our investors and our customers. And that is a really important part of the culture here because that enables people to grow. I think that, I'm not sure there is a safe bet nowadays. If you think about it, I have friends and colleagues at established companies that are in constant fear of layoffs. And these are people who've been there for a long time and they're high performers. And part of the reason that they are in this stage and companies are going through this is because the landscape is changing drastically these days. And like I would say to someone, why not be part of a company that's actually part of doing the changing? You get to be part of what's happening. You get to actually change the world.
This is a growth-oriented opportunity, right? The safer bet, you know, the best fruit is always on the furthest limb of the tree, right? And the safer bet is not necessarily the safer bet, as you said, but certainly if you're on a growth mission, a growth journey, and that's always a personal choice in life, I would always air candidates to lean on that side. Go for the growth. There's just so much amazing opportunity that exists in that growth moment.
You know, I've co-founded a bunch of startups and led them through various stages. And I have to say, when a startup is scaling, it's the most exciting time to be part of the startup. And one of the reasons is that whoever you are, you get to define the culture. I mean, the culture is getting established, but you get to be a part of that. I think Normal is in a really unique situation in that we're addressing both silicon and EDA. And in some sense, those both play against each other. We are trying to make silicon go so much faster by looking at new approaches to it. And so, at the same time, we're sort of addressing things from the EDA side. How do you design the silicon? How do you make that process faster? How do you make the people who are designing it be much more productive? And what's interesting about Normal is you kind of get to see both sides of the equation, and they guide each other.
It's not that the industry is not going to change. The industry is going to change, no doubt about it. The question is, who's going to shape it? And my bet every time is on Normal.
Normal is one of the most difficult places to work probably in the world, frankly, because of the combination of things that you described. I mean, you're sort of working at the frontier of multiple fields in an effort to push and create a new field sort of forward. I think the experience for folks at Normal has to a large extent been one of learning and kind of openness and great humility as well, because when you're truly trying to create something new, when you're really trying to push the frontier of something forward, it's difficult for anyone from any background to be the expert in all these different areas. But then you mentioned this pragmatic approach as well, of we're not a moonshot R&D lab, we're not trying to take a straight shot at superintelligence in some vacuum or isolated way. We're partnering very closely with the legacy semiconductor industry. We're in touch with real problems that will move our world forward.
I think what we saw while we were at Google X was that AI algorithms were converging towards like the equations of physics, basically. So we saw things like Hamiltonian Monte Carlo, diffusion methods, things like this that would look like physical processes. And so we wanted to build hardware to match that versus how computation is done today. What's kind of gotten clearer since then is that we can actually build that software to design our own hardware. The applications we're targeting on the hardware side are even more mainstream today than they were at the time.
Yes.
So like diffusion models and physics-based AI. One key piece of succeeding at Normal is being really grounded in like what's useful and impactful, while still having kind of the curiosity to learn outside of your area of expertise. We have folks working all the way from web app design all the way down to physics itself, and so you have to be comfortable kind of working with people far outside your area of expertise. It's looking at complexity and AI energy.
Yes, the question of delusion versus optimism has been quite core to the story that is Normal. I think it's something that you wrestle with in any environment that does R&D, whether it's an academic environment, moonshot lab, startups, deep tech startups, and so on. Optimism, to me, is the idea of believing in the fundamental tenets of technology, that technology is possible, that new things can be created, that new problems hard problems can be solved, right? This is not the final way that we're going to do computing. This is not the final way that we're going to design chips. You can have that belief, but at the same time, ask yourself the tough questions, challenge yourself, challenge each other, and kind of make sure that we're taking an approach that we feel kind of proud of.